I'm back. All right, here we go, guys. Oh yeah, January 2016. We're still on part one, but now we're going to do the second half of the part one multiple choice questions. I have no idea what page we're on. Let's guess 7. Oh, 6. That's it right there. I don't know what that thing is. We'll just delete that. I don't know what that is. Anyway, here we go. We're ready to rock and roll. Rollin' rocka. Logarithms. That's the unit we're in currently right now in class. So that's not that bad. My classes. I don't know what you guys are doing. So anyway, what we're going to do is we're going to take the log of this thing. So you got to remember the log rules. The log rules are pretty simple. If we have division, that turns into subtraction. So when we split this, it's going to be log of 10x squared minus the log of y. Stupid answers. Then we're going to split this up into log of 10 plus log of x squared, but we don't put squareds there. We put them out front. Not one of my answers. However, the log of 10 is 1. So this becomes 1 plus 2 log x minus log y, which is... Oh, choice 1. For some reason, when I looked down at my answer key, I thought it said choice 3. I'm like, it can't be choice 3. That's a stupid answer. All right, here we go. Which statement is not? This is the third time we've had the word not. I hope you kids can read. When I teach reading lessons to my students, I drink Brugger's coffee. It makes them smarter and better to pass the test. Delicious coffee. That was an approved commercial by Brugger. It isn't. They didn't pay me anything. I don't know what I'm talking about. Anyway, let's go. Anyway, correlation coefficient. The closer it is to 1, the higher or the stronger it is. So let's see. Closer to the absolute, doesn't absolute value, plus or minus 1, it makes no difference. The closer the data is conformed to a line. Yes, that's true. A correlation coefficient measures the strength of a linear relationship between two variables. Yes, that's true. A negative correlation coefficient indicates that there is a weak relation. No, that's not true. A relationship for which all data fall close to the line is strong. If it's close to the line, it's strong. The one that is not correct, which is the correct answer, is choice 3. Even though it has a negative correlation, it can be really tight. Like you could have a negative and be all right here on this line, but it would be negative. Strong linear correlation. For example, the more time I sleep and not study, the better no, whatever. Negative correlations. All right, let's move up a little bit. Ding, 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 ding. Oh, yeah, boy. What's going on? Oh, OneNote crashed on me. Let me pause. Bye. Oh, when OneNote crashes, I take an opportunity to drink coffee. All right, here we go. So anyway, here's what we got to do. I wonder if you can do this using your calculator. I bet you can. Ta-dink, ta-dink. You're going to actually go, you son of a so-and-so and such and such. What did you use? N1. I don't know if this is going to work. 3. Was it 3? 3 cosine. Oh, no. Escape. It's going crazy. Cosine. Enter. Of a fraction. I don't remember what the fraction is. N pi over 2. I don't know if this is going to work. N times, cancel, N pi over 2. Oh, are you kidding me? That worked. All right, let me make sure that's the right answer. I'm pretty sure it is. I don't remember. All right. For those of you that actually did it the right way, it's cosine of 1 pi, that's a pi, by the way, it's just a really straight, over 2, which is the cosine of pi over 2, which is 0. And then we've got the cosine of 2 pi over 2, which is the cosine of pi, which is negative 1. And then we've got the cosine of 3 pi over 2, which is 0. So when you add those up, you get negative 1. That's why it's negative 1, but whatever. You could just use a calculator. The roots are, so here's an example of something, if you wanted to, we could just graph 4x squared minus 1 equals negative 3x. We just bring this over, make it positive 3x. Let's see what that looks like. I don't even know, because I didn't have a calculator around when I was making this answer key up. So we'll go into graph mode. Ding, 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 ding. Come on, graph mode, enter. And we're going to go 4. I hate having all this stuff open. It drives me crazy. No. I don't want to save this crap. Okay. Ba-ding. All right, so 4 parentheses, I don't remember. X squared minus 1. All right, you guys don't think I need a calculator. And every time I hit something, I get something else. 4x squared minus 1. And was there anything else? Plus 3x. So plus 3x. It's a parabola. What's going on? Now, I really can't tell what the roots are. I could go into menu, analyze the graph, and do zeros. Left, right, and it looks like my 0, but this is probably in like, oh, it is in float mode. It says 4.4. I don't know. That looks like it's going to be, that looks rational, but that's kind of tricky. I don't think the answer is rational. So let's take a look and see what this looks like. 4x squared minus 4 equals negative 3x. I'll pop that over, put it in the middle. 4x squared plus 3x minus 4. And I hope your teachers taught you that when you're talking about the nature of the roots, real, imaginary, rational versus irrational, really what you want to take a look at is the discriminant, b squared minus 4ac, which in this case is b squared is 9 minus 4 times negative 4, which I believe is like 73-ish, maybe, something like that. So we're going to do 9 minus 4 times negative 4, and we get 73. So 73 is, first of all, not negative, so it can't be imaginary. It's not equal to 0, so it can't be equal roots, and it's going to come down to one of these two. And the difference is right here, rational versus irrational. And since I can't take the square root of that, the answer is irrational. That's why that graphing one was a little bit tricky. So what are we going to do with this x plus 3? What we're going to do with this x plus 3 is everywhere we see an x, we're going to put it. So f of x plus 3 is really equal to 2 times x plus 3 squared minus 3 times x plus 3 plus 4. So this one, I'm not going to go through this too much. This is just x squared plus 6x plus 9 minus 3x minus 9 plus 4. Now, if I distribute this, I get 2x squared plus 12x plus 18 minus 3x minus 5. So this gives me 2x squared plus 12x. No, not plus 12x, plus 9x. And then 18 minus 5 is 13. Choice 3, kids. There it is. In all. By the way, oh yeah, no, that's good enough. All right, so this one. So let me show you what I would have done on this problem. I would have stowed any number in for x. 3.32. We're going to stow that in for x. And we'll hit enter. And then we're going to type this in. X, parenthesis, 3i squared cubed 3i squared. By the way, I would not have done it this way. I'm just saying if you just don't know what the heck's going on, you might want to do it this way. Plus 2x I raised to the 12th. Oh, sorry. Ding, ding, ding. Oh, whatever. Shut up. Ding, ding. Really having a lot of fun here with this thing today. Enter. All right. Well, you could type that in. I'm not sure why it's not working there, but you could type this in. But honestly, this is what I would do. First of all, I squared, you should have memorized it by now. I squared is -1. So this becomes x times -3 cubed plus, now this is a multiple of 4, which just means it's 1. So that's plus 2x. So -3 cubed is -27. X plus 2x is -25x. I don't know why it didn't work out. If the terminal side of the point passes through, so let's plot that point, -3, 1, 2, 3, 1, 2, 3, 4. There it is, the terminal side of my angle. So you got to do it with reference angle. So I'm talking about this angle. Don't forget to make a triangle. Ding, 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 ding. So this is 3. This is 4. You should know this is 5. Now, we're in the second quadrant. -3. Oh, son of a so-and-so and such and such. I'm in the wrong quadrant. E raised. I said third. I don't know if I said second, but I meant to be in the third. Let's do this. -3. 1, 2, 3, 4. 1, 2, 3, 4. So -3, 4 is right here. So there, -3, -4 is right there. So let me make my triangle. I'll do it in red. That's the terminal side. This is 3, this is 4, this is 5. Yes, you notice I didn't put signs on them because they're lengths. They can't be negative, but whatever. So anyway, what we want is secant. Now secant is really 1 over cosine, or it's cosine flipped. And we know that cosine of a theta is equal to, some old horse caught another horse, or another hippie, 3 over 5. But we're in the third quadrant, so it's -3 over 5. Now, since cosine is -3 over 5, secant is -5 over 3. Ka-ching! Moving on, kids. Let's go. View. Boom, boom, boom. This one's kind of tricky. Not going to lie. So if you remember correctly, the inverses, when you're dealing with inverses, domain and range flip. So what do I mean by that? If I graph the tangent curve, I'm going to graph the tangent curve right here. The tangent curve looks something like this, where its domain is from -pi over 2 to pi over 2. That's the domain. Well, then on its, if I come over here and graph its inverse, which I'm not really going to graph, then this one's range would be -pi over 2 to pi over 2. Because remember, inverses flip-flop their domain and range. So if my domain is this, the inverse is range becomes that. Well, then let's think about what the range is here. Well, the range is up to positive infinity and down to negative infinity. That's the range of my original function, tangent. So its inverse will go from, the domain will go from negative infinity to positive infinity. So the answer is choice 4. Tricky question, I know. All right, so this one I'm going to show you 2 ways to do it. I'm going to show you the easy way and the hard way, because that's what I do. A1 is equal to -6. A2, this is where n equals 2, is equal to 1/2. Now, n minus 1 just means this number right here. So times -6 minus, remember n is 2. Well, let's see, that's half of -6 is -3, minus 2 is -5. So a sub 3 when n equals 3 is half of negative 5 over 1 minus 3. So this is negative 5 over 2 minus 6 over 2, because 3 is really just negative 6 over 2. Negative 3 is really negative 6 over 2. And this becomes negative 11 over 2, which is why this is the answer. But quite honestly, you got to learn to do recursion on your calculator, kids. Let me get rid of all this mess that I have here. And I'm going to take negative 6, and I'm going to hit enter. And then the rule says take 1/2, control division, 1/2, times the answer, minus 2, enter. And then we're going to take 1/2 times the answer minus 3. Oh, how do I get a stove font? Yes, I know. I need a new computer. Anyway, negative 11 over 2. It was supposed to pop negative 11 over 2. I didn't know why I didn't. All right, what is the equation of a circle centered? Centered here. So centered means at x, we should have x minus 0, which is just x. So that means it has to be 3 or 1. But now you have to find the radius. 0, negative 2, 1, 2, that's this point. And 3, negative 5. 1, 2, 3, negative 5. 1, 2, 3. 3, negative 5. So my circle is going to look something like this, but I have to find this distance. And the easiest way to find that distance is just to count. This distance is 3, and this distance is 3, and this distance is x. So that radius, which is right here, is equal to, radius squared is equal to 3 squared plus 3 squared. So radius squared is equal to 18. And remember, the right side of the equation is radius squared. So there is your answer, chillin'. Oh, yeah. So this next one was kind of difficult. Probably had a hard time with this one. Just want to make sure I haven't made a mistake yet. No, got that one right. I got that one right. Next page. Sorry, kids, just checking. Got that. We chose choice 3. Good. Chose negative 11 over 2. We chose 4. Good, good, good. Just check them. I don't want to make a mistake. You guys would make me mad. You guys would be mad. So cofunctions are complementary. One of the things you have to remember is cofunctions are complementary. So the cofunction of secant is cosecant. And what I mean by complementary is their angles, whatever this is, plus whatever this is, has to add up to 90 degrees. So if I take B, B, and I add B minus 90, do those add up to 90 degrees? No. But I chose the wrong one. They're cofunctions, and here's the cofunction. This is the answer right here. If I take B and I add 90 minus B, do those add up to 90 degrees? And the B's, you'll notice, cancel. So I end up with 90 equals 90. So cofunctions are complementary, which means their angles have to add up to 90 degrees. And their cofunctions, those are equal as well. All right, that's the answer to that question. Moving on. Yeah, this one wasn't bad, but the way it was worded was a little bit tricky. You got to be careful. So what we're going to do is take a right triangle, and this is going to be x minus the square root of 2, and this is going to be x plus the square root of 2. And this is my hypotenuse. So my hypotenuse squared is equal to x minus the square root of 2 squared plus x plus the square root of 2 squared. So I have to double distribute this one out. Let me do it in a different color. So I'm going to multiply by x minus the square root of 2. We'll do this one. So this is x squared minus x square roots of 2 minus x square roots of 2 plus, because negative times negative positive, and the square root of 2 times the square root of 2 is just 2. This one, if I double distribute it out, I get plus x squared plus x square roots of 2 plus x square roots of 2 plus 2. Well, this and this cancel with this, and it leaves me 2x squared plus 4. And that's the answer to that one. And I got that one right. Yay, last problem. Oh my gosh, I felt so bad for you because I know some of you guys screwed up on this one. Amplitude. Amplitude describes how high or low your curve is going to go. How much amplitude, how much fluctuation do you have? It is always positive, which means these answers can't be right. Amplitude must always be positive, and it's positive 3. I don't care about the negative. The negative just tells you which direction it's going to go first, and that just gives you a reflection. And then you got to remember the formula for period, and the period is 2 pi over b. Now that's another thing that makes this tricky. The b is right here. It's this thing right here, which is 1/3. So b is 1/3. So what you end up with is 2 pi over 1/3. Now dividing by 1/3 is the same as multiplying by 3 over 1, and you get 6 pi. So the answer is choice 4. And I bet a lot of you missed that one. That was a very, very tricky question. All right, kids. Oh, yeah. Done with the multiple choice. Click on the next video. Hopefully you rocked the part 2s, 3s, and 4s. All right. I'll be back in a little bit. And until then, have fun. Bye.